partner with to go look at doing some potential sample returns, looking at in-situ resource utilization off the surface of the moon, etc. So this is a kind of a way, again, to see what industry's interested in doing, and is there a way that NASA can come alongside and help out and become part of a public-private partnership. So again, I think you guys are part of a pretty exciting conference. I think this is clearly the new way of doing business going forward. And really, really important for us to keep exploring and moving forward, and I think we can do it with this public-private partnership thing, and we on the government side need to find ways where we can really help and actually enable what the private sector wants to do, and we can expose to the private sector what we'd like to do from a public standpoint and find that partnership to keep us moving forward. So that's really all I wanted to talk to you about from a kind of an opening remark standpoint, and maybe I can get a chance to answer any questions if there are any, or if the time allows.
Thank you, Bill. So we have mic runners on both of the aisles. Mic runners, if you would raise your hands. Because Bill is on Skype, please make sure to wait for the mic. And we'll be taking questions right now.
Hello.
Hi, Bill. This is Ivan Rosenberg. Good to see you. So all kinds of good stuff. What do you see are the major challenges in this private-public partnership that need to be dealt with over the next couple of years?
Yeah, I think that's a very interesting question. I think, again, with anything that's a new way of doing business, there takes some time for this new approach to really become accepted and adopted. You know, especially in the Washington environment, you know, many of my congressional friends, this is a new way of doing business. It's not the typical big NASA program or government-run program. We're actually, you know, kind of sharing risk with the private entity, which is a very different way for our congressional friends to see things. So you're seeing, you know, lots of, you know, concern from the congressional folks. Are we mindful of the taxpayers' resources? Are we doing the right things? So I think we need to continue to nurture our relationship with Congress and with our stakeholders to make sure they understand exactly what we're doing and how we can take maximum advantage of what's available in the private sector and what's available in the public sector. So I think that's one challenge we've got to work collectively, that with anything new that comes online, there's a challenge associated with that new thing coming online, and I think that's one of the biggest hurdles we have to overcome.
So I have two questions. One is, when you refer to cases and the $15 million budget that is allocated to it, my first question is, what's the heritage of cases to the former space development program run out of Marshall Space Center? That program, to my understanding and knowledge, was very successful in engaging commercial companies to use the microgravity environment, and it generated a lot of products. So what's the heritage there? And if you also could compare the budget that the Space Development Program had with the budget that is right now allocated to cases. Thank you.
Okay, again, I think the thing that I see with cases that's unique is they have the ability to do certain things that we could not do from a government standpoint. You know, they can actually go out and they can market space station to a sense, and the government side, we're not allowed to go do that. Cases can also talk to commercial companies in a way that a commercial company is being used to talk to. In other words, they can actually go out, investigate with them what's important to their board, what's important to their research avenues, etc., whereas NASA is restricted from getting that same insight into the company. So I believe cases carries degrees of freedom that we would never have on the government side. And we've been pretty successful with many agreements that, as you just described, from Marshall. We've done some from JSC as well. And we've transitioned some of those agreements that NASA put in place over to cases to go ahead and manage. But I think the big advantage here is that CASES has degrees of freedom that I think will be very important in this commercial private sector market that we on the government side could never have or could never get. In terms of the dollars spent, we probably are spending 50 to roughly 100 million of NASA-based research. That's stuff that actually needs to be done for NASA compared to this 15 million that we give into CASES. But part of the challenge is in the cooperative agreement notice with CASES that we've signed with them, they're out to not only use this money but for their purposes, but it's also to leverage funding or dollars from the commercial entities themselves. So if you think about it, what we've been able to do is essentially you can get a ride to space for free on the commercial cargo providers. We have enough room so far to actually allow a commercial company to fly their activity to space for free. They can get telemetry, crew time, basic power, thermal control, all those things on board space station, again, for free. If there's a small sample return, they can also get that return to the Earth, again, for free. So the only thing we're asking the commercial sector to do is to do the thought process of put together the basic research to get their equipment ready to go fly and then to go fly it into space. So we think we've lowered that barrier of entry as much as we can to see if this market can get established with all these other barriers removed. And it's still not trivial. I mean, we're still asking these companies to take a shot again at something that's very different. You know, they're very used to controlling their own research programs, their own research timelines. We're trying to knock down all those barriers to fly as fast as we can, get them results as soon as we can, and let them experience what they can really learn from space. And then they have to learn on their own how they can use space effectively. So we'll see how this goes. I think this is absolutely critical, this phase. If we can show that there is a market in space, and then we've established both the cargo transportation and the crew transportation in this market, then we're about ready to see a new economy, or we're about ready to see an industry take off in space.
This is David Gump with Deep Space Industries. I have a question about the Asteroid initiative. For NASA, the long-term value of asteroids are volatiles and materials to make NASA exploration less expensive, and supplying that to pretty grubby industrial activity. How do you see the private sector being involved in the overall asteroid initiative?
Again, I think there's a very strong interest from your company and some other companies in doing some asteroid activities. And what we've got to make sure is we don't inadvertently do something that actually hurts the industry that's beginning. So when, you know, in the beginning of this talk, I talked about a public-private partnership, and it truly needs to be a partnership. You know, we on the government side, we can do things that actually slow down or actually hurt an industry, and we've got to be very careful we do not do that. We need to do things that are nurturing and helping an industry to continue to move forward. We definitely, on the NASA side, see asteroids as a potential for propellants, for activities that fit in our exploration missions, and we want to leverage off of what you're willing to do and what the commercial private sector is willing to do in these activities. We just recently did an RFI to go look at this asteroid retrieval mission. We got 402 responses from the commercial international sector on that RFI. And those responses are amazing. I mean, there are some really creative thoughts in those responses, some really good ideas. And so now we're in the process of kind of distilling those down again. We'll do another meeting at the end of September where we actually get together with the private sector to see how we can start moving forward. So we're going to be careful as we move forward in this. We're going to figure out a way that we can reap the maximum benefit out of this activity and make sure we don't hurt the private commercial sector as we do that. But NASA has a very strong desire in taking advantage of breaking that tie with the planet and using the resources that sit out there in the solar system to allow us to go explore. So, as I described to you in the charts where we talk about 3D printing, you know, maybe we can do some things along those lines, even from an asteroid. Can we repurpose some of the materials into other components that we need to actually push us further into exploration? So this is the first step of us starting to break the tie with the home planet, which is a huge way of going forward. So we're very interested in working with you, and we sure thank the community for all the responses we got to the RFI.
Good morning, this is Gary Olson Task. And what capabilities or services that we don't currently have do you see as most important to enable expanded commercial activity in space?
Yeah, I heard the first part. Could you just repeat the last part about where the services were?
Okay, what capabilities or services that we do not currently have do you see as most important to enable expanded commercial activity in space?
Is that the benefit of space-based research to commercial companies? There's very intriguing findings in the biological world, as I described to you. There's also some very intriguing funding or findings in the materials world, where we can look at some alloys that are pretty interesting. We can also do some things in terms of precision forming of some materials without the effect of gravity. All those have interest in the private sector, and they have advantages to the commercial sector, but yet we still haven't crossed that tipping point where a commercial company says, I have to be doing space-based research to be competitive in the global market. So I think we've got to use station as kind of a proving ground or a test bed to let some of these companies and some of these creative folks see that there is really a market in space for them. And then once that occurs, and when I start getting commercial industry or private industry say, hey, we need to be in space to be globally competitive, then we've really crossed that milestone that I'm really interested in seeing as it happen. So what we're doing now is, I think we're still in that impact startup stage, and we've got a finite amount of time with space station to use it to prove to the private sector that there really is an advantage to them to do space-based research for terrestrial applications.
We still have some time for questions. Any more questions? Okay. Well, I'd like to thank Bill Gerstenmaier for the keynote speech and the Q&A.
Thank you very much, and have a great conference.
Thank you. So we're a little bit ahead of schedule, but while I introduce the next panel, I'd like to invite the panelists to the stage. So for the rest of the morning session, we'll be looking at how to evolve the business as usual, whether it's taking partnerships to the next level or adapting to new technologies. The next panel is titled New Wave of Public-Private Partnership, and Bill gave a great introduction to the conference, and this is a great segue into this panel as well. And we'll be discussing the past, present, and the future of PPPs for space. Alex MacDonald from NASA's Emerging Commercial Space Office will be our moderator for this panel. Please welcome Alex and our panelists.
Well, good morning, everyone. Welcome to NewSpace. It's really exciting to be here. As Curtis said, I am the program executive for NASA's Emerging Space Office. And the Emerging Space Office is a function of the Office of the Chief Technologist at NASA headquarters, dedicated to providing economic intelligence on the emerging space ecosystem. And I think Bill Gerstenmaier did a really excellent job of summarizing the rise of public-private partnerships, how extensive they've become in the current stage of NASA planning and NASA programs. And I would simply add that, I think the existence of something like the Emerging Space Office is another interesting signal as well. It's a signal that the agency recognizes the need for a constant economic intelligence process to understand all the different activities that are going on in the commercial space sector. And I'm very excited here to have a rather august panel with us. And I'm going to introduce them in a quick set. We got no slides, no presentations. One of the greatest things about NewSpace is you know, the sitting around on the couch and talking about what's going on in the industry. So we're doing the sitting around the couch kind of thing. It's going to be good fun stuff. And I guess I just want to do a little bit of history for just a quick second. You know, prior to the existence of NASA, there was a lot of work in space development, space exploration, conceptual development, liquid fuel rocketry technology, and of course astronomical observatories. And of course, if you look in the 19th century, pretty much all of the ideas for spaceflight, and the first Americans were starting to think about spaceflight, were doing so in the 1840s. They all thought about it being done exclusively as a private endeavor. And it was really only until the 1880s when John Jacob Astor IV wrote his science fiction novel on spaceflight that the idea of a public-private partnership was even mentioned. And the unique part of that was the public part, because of course prior to that, everyone thought it was going to be done entirely privately. And of course, you know, Robert Goddard represented another type of public-private partnership, largely funded by the Guggenheim family, funded by his own salary as a university professor. And then the Guggenheim Foundation partnering ultimately with the US military at the start of the Second World War to take his early developments of liquid fuel rocketry to a rather extraordinary attempt to build a liquid fuel rocket jet-assisted takeoff device. Needless to say, it didn't work out terribly well, but it was an attempt by him to develop liquid fuel rocketry for spaceflight, using whatever type of partnerships we could get to. So here we are today. Public-private partnerships have come back into the fore, into the mainstream, and I think I'm going to sit down on the couch. Our panelists are rather extraordinary. We have Carissa Christensen, who is a founder of the Tauri group, one of the real true empirical data hounds for the space industry. She has been at the heart of a huge amount of the empirical databases that we've seen track the space industry, from the Satellite Industry Association's database, the Futron database, when she was back working at Futron, Space Foundation report, the early days of that, and she is really truly one of the great specific and empirical minds that I see in the DC area. We also have Howard McCurdy, Professor Howard McCurdy from American University in DC, one of the truly great scholars of American space policy. If you haven't read Inside NASA or American Spaceflight Imagination, that's the right title, Space and American Imagination, or Faster, Better, Cheaper, or The Space Station Decision, you really need to. These are really absolutely critical works for understanding policy development and the various forces and dynamics of space exploration and history. We also have, of course, one of the long-standing bureaucratic warriors of NASA, Dennis Stone. Dennis Stone is part of the Program Integration Officer, is that right? For the COTS program. Been there from the start at JSC. Really critical in advocating for the need for partnerships within the agency as part of the mainstream of its development for decades. And we also have one of the renewed faces of NASA, which is Jason Kessler, who started off as Dan Golden's exec, then became Dan Golden's deputy chief of staff, and then of course, you know, as one must do, went to the private sector for a little bit, started a couple companies, and is now back in a very exciting new role as the agency program executive for the agency grand challenge of protecting the Earth from asteroids, which is part of the Asteroid initiative, and a really exciting new development. It's an initiative that has public-private partnership at the core of its process. And last but certainly not least, we have another former NASA bureaucratic warrior, and now current star of the entrepreneurial space community, Robbie Schingler. Robbie was the former chief of staff of the Office of the Chief Technologist under Bobby Braun, and he was also a colleague of mine at NASA AIM. And he now is one of the co-founders of Planet Labs, formerly named Cosmomia, which has raised over $10 million from venture capitalists, some of whom may be in the room, and really are doing some really incredible things. And actually, I might add, we've already launched 2 satellites and we're trying to juice from those satellites. That's the most important part. Okay, so diverse, exciting group. I'm going to start out by doing an awesome thing, which is reading from a book 20 years old, which is Howard McCurdy's Inside NASA. And it's written in 1994, published in 94. And I think it's got a very interesting introduction and part of the conclusion, which is a challenge to NASA, really. I mean, Howard has hardly been a fanboy for the agency. In fact, this was a very critical work, and I think that's exactly why we need to understand and deal with the critique that is there, and what's actually changed in the 20-year period. So get ready, we're now to review words of 20 years ago and what's changed. So, introduction. Popular wisdom holds that government organizations inevitably decline. They start out with great enthusiasm, but eventually their capabilities wind down. They grow excessively bureaucratic. Their employees resist new ideas, overall performance deteriorates. Skepticism about the capabilities of large government agencies is an important part of American political life. Does this belief stand up to scrutiny, or is it just part of the natural antagonism towards big government in a democratic society? The people who ran the National Aeronautics and Space Administration, NASA, when the agency was young, developed methods of doing business that allowed them to carry out extraordinarily difficult tasks. NASA civil servants discovered ways to circumvent bureaucratic restrictions and avoid failure when it threatened to occur. They adopted an organizational philosophy suited to the technological and scientific missions they were asked to perform. NASA acquired reputation as a high-performance government organization. As NASA grew older, it changed. Beliefs about how the agency should be run persisted, but no longer did those beliefs elicit the behavior that characterized the early years. NASA grew more bureaucratic, became more concerned with maintaining its survival. In the eyes of some people, its performance declined. The onset of maturity changed NASA. That's the introduction. Let's go to the very final words. NASA's early culture developed for many years before it blossomed during the first decade of space exploration. The period of transformation that followed took place over 2 decades. If NASA is to fashion a culture that is both successful and mature, it too will be years in development. All right, so we're years past now, 20 years past those words. When you look and you see the types of public-private partnerships that have driven the COTS program, that has driven agreements with Bigelow Aerospace, is that potentially a return to some of those earlier energies of NASA, trying to find ways to circumvent bureaucratic restrictions, to return to a scientific and technical culture appropriate for the problems of the day and the constraints that we see. Is NASA on its way, in some respects, to becoming and finding a model for success and becoming a mature organization? NASA as 50 years young rather than 50 years old. Thoughts?
Okay, let me make 2 points quickly if I can. First, public-private partnerships are the normal way of doing business in exploration. The abnormalities are NASA and also Antarctic exploration. It's interesting that Norm Augustine, who's commented extensively on the American space program, was brought in to look at the American Antarctic program, which is experiencing the same difficulties that NASA is experiencing, since it is an exclusively government-run program. You cannot go to McMurdo without the permission of the National Science Foundation. It is not a public-private partnership. So it's the norm to have public-private partnerships in astronomical observatories, in the aviation industry, in the intercontinental, the transcontinental railroad, in other areas as well. And I have just finished a study on mountaineering, which if we get a chance, I'll describe some of the findings from, as to how that progressed. Very different than space exploration. So we're returning to the norm. We're not developing something new. And the second point is one I'd like to make about the history of NASA. In 1961, when John F. Kennedy said we should go to the moon, there wasn't anybody in NASA who knew how to do it, and they weren't organized to do it. At that time, people predicted that if NASA actually reached the moon in 1969, it would be an entirely different organization than it was in 1961, when it was really just a collection of government research laboratories that were used to very small research project organization. They didn't know how to do large-scale systems management, and that technique had to be imported from the U.S. Air Force ballistic missile program in order to organize NASA, to organize itself to go to the moon. Stephen Johnson's called large-scale systems management the secret of Apollo. In the same way, if NASA reaches out to the asteroids and out to Mars with robots and humans eventually, it will not be the same organization that it is today. It will undergo some sort of transformation. It will be as different from the NASA of today as the NASA of 1969 was to the NASA of 1961. And I think that that would take the form of public-private partnerships. The people who are really motivated to explore space are out in the general community. They're not necessarily in the government. The government has multiple obligations that it has to follow. Those were overweighed by the Cold War during the 1960s, but they're not being overweight today by any single event. So this is going to be a transformation, but not to something new. It's probably going to be a transformation to something very old, and therefore it behooves us to understand these other sectors that have gone through the process in ways that are different than NASA went through.
Yeah, no, thank you. That's exactly what I was hoping you were going to be able to elaborate on. And we're going to get to talking about the study in a bit. The study I'm very proud that the Emerging Space Office was able to fund. And I think that understanding these analogies actually is critically important. And I think one of the other most interesting things and important things that McCurdy just mentioned was that the will to go
here, there's
is this intrinsic individual phenomenon that really has been the driving
pretty close to
majority exploration. And that's what we're
the
seeing
woman behind
turn
this
for.
podium's talking. I'll get it from the other angle.
We're going to throw it over to Carissa now.
But
So
yeah,
Carissa,
just kind of follow along.
in your empirical specific mind, what are some of the most interesting pieces of data, most interesting figures, empirical phenomena that you've seen in your time in the charming Washington, D.C. environment?
Well, I do enjoy the Washington, D.C. environment.
Who doesn't?
I want to say that I think that it's impressive that on this panel, Alex says, I think managed to make me sound nervous. So, I do believe that good data leads to good decisions. Anyone who knows me or has worked with me has heard me say that many times. And I also think that it's very interesting because there's often a tension when it comes to innovative entrepreneurial ideas and data analysis. And the tension exists in the following place. I see potential for transformation. I'm an entrepreneur, and I know that the world can change and we can have iPods. I know that the world can change and we can have Starbucks. Big or small, there's potential for change, and that's what entrepreneurs see. The data analytic piece associated with that often says, well, nobody's ever bought that before. Nobody appears to want that. When we ask them, they say they're not interested. How does that fit? That there might not be the kind of market that you're talking about. And I think that that tension is valuable and important and productive as opposed to limiting and destructive. I think that it can be perceived as saying, oh gosh, the data, as we know the world now, says this, your vision says this. It's useful to understand that. It's useful to understand that in terms of talking to your investors, in terms of making your plans, that your success story requires that the world change in these important ways. Knowing that, communicating that, and managing that leads to success. So I myself am an entrepreneur, and I am an enormous fan of entrepreneurship. I do think, though, that data is important to support. So a couple notes. In the mid-1990s, and I'll speak to how that benefits companies with the government. In the mid-1990s, we did some work with the Satellite Industry Association to try to figure out what the size of the global satellite industry was. And at a point, after we started doing that, total international government space expenditure was actually outpaced by satellite revenues. So at that point, there was a tip. I remember, where suddenly commercial space, satellite industry's commercial space, was bigger than government space. Well, that was a noteworthy historical point, And it also helped to start to shift the way that people in government thought about the satellite industry. And now let's fast forward to today, 15 years later, still collecting that data. And there's a conversation going on with the Department of Defense, which has brought a massive amount of commercial satellite capacity, partly because its needs grew with UAVs and the growth of mobile systems, partly because there were some performance failures in plain DoD systems. At one point, the DoD was buying more than 80% of its SATCOM capacity from commercial providers. So the conversation today with folks at the DoD, and which views itself as it should, as an important customer, and it's probably the largest customer in the world in commercial satellite capability, but it buys maybe 4 or 5% of the world's satellite capacity. That's not a dominant customer position. That's a position in which you need to engage with and work with the industry, manage your policies and procedures so that you can get a good deal and that you can be assured that CNN is not going to beat you out with the transponders that you need. So that, to me, is a really interesting and good example of how the world changes, and you move from that transformative point, that point where the government is absolutely the dominant customer, to the government is part of a customer set and operates quite differently.
So, satellite industry metrics. I'm also an economics nerd. My favorite number for public-private partnerships, of course, is related to the NASA NAVCOM study on how much NASA estimated it would have cost to build the Falcon 9 versus what the SpaceX actually is worth. Can you talk about that a little bit?
I absolutely can. So without being, so NAVCOM is a cost estimating tool that many of you may be aware of. And what it is, basically, it's a great tool. It was a great idea. The Air Force said we need to do a better job of understanding what space systems will cost. Let's gather up all the information we have on our different space development programs. Let's package that up and we'll look at the key attributes in terms of the size of the system and its functionality, the time frame, the degree of technology, complexity, and innovation. We'll build those metrics into a modeling tool, and that will let us, with some systematic approach and some rigor, figure out, you do cost estimates because we keep getting it wrong. So a great idea and a really important tool that's been very useful. However, what is embedded in that, as you'll have already seen from my description of it, is that you do everything the way you have done it. So you build and you design and you evolve a system in the way that the Air Force and NASA have done in the past. And that is not necessarily how a company approaching a project with its own frame of reference and its own attitude toward risk and its own priorities and its own ability to make decisions will operate. So and I don't have the number off the top of my head because I did not do that study. It was a significantly higher order, several times higher.
The factor of 5 was the revised estimate from
than the actual cost. And I'll sort of put in a note here on, I think that whole question of what dollars does the government put in and what output does the government get out is really important. I think that when you talk about public-private partnerships, you get into there's a bit of a danger of getting into a religious war over what commercial means. And I don't know that I think that that's always all that productive or useful certainly from a government decision maker's point of view. I think that the question should be, well, what money did we plunk down and what outcome did we get? And so let's look at the Falcon 9 and SpaceX generally, and NASA has absolutely provided a lot of funding, a couple of $1 billion to SpaceX. And SpaceX has produced with that funding, as well as with private sector funding, as well as with DoD launch contracts. SpaceX has produced a small launch vehicle, a large launch vehicle, a capsule, facilities, several successful launches, including one that was his history that came a commercial launch to the space station. That's a lot of output for that amount of input. And so I think that those kinds of looks are really important.
Yeah, I agree, and two important things there, the output, and also for the ambitious data nerds out there, understanding the programmatic limitations that a complete reliance on historical data for our cost models is putting on our space systems is an absolutely critical if potentially not a sexy problem that we are frankly dealing with within this broader public-private partnership ecosystem. Understanding how to overcome some of those historical limitations is not an easy problem at all, and one that requires us to very seriously think about. But enough of the boring data analysis. Let's throw it over to Robbie Schingler, man about town, entrepreneur, satellite builder, and flyer. Robbie, let's start off with your history at NASA. You were really at the heart of a very exciting program, the establishment of OCT. When Bobby, Ron came on to lead it at the start. A lot of discussion, a lot of program establishment around public-private partnerships. Tell us about some of the lessons and techniques that you learned of within the system for establishing these partnerships, getting them done, making them successful.
Sure. So I don't think it starts with OCT. It's spending a lot of time at Ames, where you have tremendous facilities and people and a brand, and not a lot of money is actually where you can get some interesting stuff done. You know, being a bureaucratic warrior is really being an entrepreneur in government. So leveraging the resources that you have in order to do new things. And if you are an entrepreneur or a bureaucratic warrior, you see the future that you want, that you seek, and you assemble a team in order to go do it. You get some seed funding from someone somewhere, whether it's a Center Innovation Fund or whether it's you know, some sort of competitive award. Then you work really, really hard in order to get it done. And many new programs. COTS is a perfect example of that. And hopefully, Dennis, you can talk about the foundation of that and how that got started. But it wasn't easy, right? You have to work on it continuously, and it almost dies many times. And that's the same type of attitude, of course, that you need when you're doing a company, right? You have to find your seed funding, you have to find your founders, you have to find your early team, and you have to work really, really hard in order to get it done. So there isn't a whole lot of difference between starting a company and starting a program. You have different stakeholders, but it's the same type of skills that you learn in order to get that done.
Yeah, no, it's a really good insight. I mean, essentially, you've described different entrepreneurial experiences just within, frankly, different economic ecosystems. One of which is the roughly $18 billion in shrinking NASA ecosystem. And the other is the much larger and growing ecosystem of, well, frankly, Bay Area entrepreneurship, venture capital investing, and startup culture.
Yep.
So tell us now a little bit about that transition. What's it been like? Leaving the government, starting up a small satellite company with your friends, building satellites, launching them in space.
So at NASA, we always thought that we could do satellites very, very differently. We can, from an engineering perspective. But in fact, a few friends, we wrote a paper called ROSI, the Return on Science Investment, which was intended to think about put probability of success in front of your missions to get around the NAVCOM issue, right? And let me get back to that in a second. So back on NAVCOM, the majority of NASA's missions are all competitively selected. And if you know your reviewers and you know the review processes, you know what you have to put in order to be selected. And so you end up putting in something that people will find indeed selectable, and therefore very, very close to NAVCOM. And as a result, with a fixed budget, you end up not getting as many innovative things as you necessarily want. So ROSI was an attempt to academically discourse around thinking about if you are a program executive or you are a mission directorate, think about being a VC, having a portfolio of investments out there, some super high risk that may have a huge return, and some that are totally mission critical that you know is your bond, that you know that you can actually continue to achieve your mission. But I think that that's an extremely important way to think about it. Now, in leaving NASA, it is a different ecosystem. And by being an expert in space and the team which we brought together, we were able to convince the right people that we were the team to to take on the appropriate risk and the appropriate elements of our business. So the differences are not large. Building a team, inventing technology, having persistence. It's all exactly the same thing if you are a bureaucratic warrior versus an entrepreneur.
That's really good. We're going to ask you about, what you're up to in the company in a bit, but I want to throw it over to Jason Kessler. So Jason, you're kind of on point on a really interesting process, right? The White House sent out kind of a request to the agencies for grand challenges. Right? We've seen grand challenges emerge from a number of agencies, from the DOE, from NIH, and now from NASA. So before we get into the specifics of the NASA kind of grand challenge, just tell us a little bit about what you think is driving that high-level executive branch interest in this overall process of grand challenges, which are inherently being conceived of across all the agencies as public-private partnerships.
Thank you, Alex. I think from the White House perspective, there's a recognition that leveraging the taxpayer dollar in new ways to bring about innovation that wouldn't happen in that government ecosystem that we're talking about is a really good thing to do. That innovation is going to come from bridging across communities and bringing new people into the conversation, because those ideas will facilitate potentially radical change in the work that's being done. And so it's a recognition that the seed kernel that government investments can be nurtured through a public-private partnership effort like a grand challenge.
Yeah, and I think what's very interesting about the Asteroid grand challenge is, it's essentially a recognition of something that's been going on really for some decades in the space community. I mean, people who've been leading a lot of planetary defense have really been in the private sector. V612, right, for a long time has been a private sector nonprofit champion of the importance of this idea. Not a government program, and yet at the front of cultural change, analysis, a number of new mitigation techniques that have been proposed from that organization. And taking it back to the Innovative Center Director of NASA Ames, when Pete Warden ran a number of the first workshops, those were really very much his initiative because he believed it was important. Again, acting as a kind of bureaucratic entrepreneur rather than representing the Air Force's programmatic beliefs that this was a critical issue. It was very much something that he thought was important and was taking on. So tell us about what this initiative is, what's been announced, how do people here participate, all that.
Great. So on the 18th of June, we announced the second piece of the Asteroid Initiative, which is the Asteroid Grand Challenge to find all asteroid threats to human populations and know what to do about them. And as you mentioned, Alex, there has been a strong private effort in this work already. There's also been a tremendous effort within NASA as well as the other space agencies around the world to figure out what's out there. And the NASA-led Near-Earth Object Observation Program has found 95% of those asteroids that are a kilometer or larger. So the focus was on the really big stuff that would do really bad damage if it were to impact the Earth. The difficulty is that there's potentially about 1 million smaller threatening asteroids out there, and we don't know where they are right now. And I think the exciting thing about NASA's first grand challenge with the support of the White House is the recognition that this is a very serious global threat, and it's something that NASA can't do on its own. NASA gets asked to do a lot of stuff. It does the best that it can. I cut my teeth at the agency in the 90s, left and came back, and Professor McCurdy was talking about the excitement and life that's out in the community. I will say that in the NASA community as well, it is still strong and thriving. The constraints are different, the ecosystem is different, the environment is very different, but there is a fundamental drive with the majority of folks at the agency. So NASA's done really good work on near-Earth objects, but we can't do it on our own. And so having the Grand Challenge, the core of that is finding partnerships, and particularly non-traditional partnerships. I want to focus in on that because one of the things that we might default to in a public-private partnership mindset are the people that we know. Maybe it's the folks that we worked with or we went to school with, and so our conversation doesn't expand as broadly as we really want it to, or ultimately that it should. And so the exciting part for me about the Asteroid Grand Challenge is that it enables a global conversation because this is a global threat. This is a problem that we have the ability to find solutions for. We're working on it already, but we have the ability to truly change our fate. There are not many things that we can actually look ourselves in the mirror and say that about, and this is one of them. And it enables a conversation that we weren't having before, at least within the agency. And I'll give an example of an email that I got from a young woman that is building telescopes. She thinks she can get a meter-sized telescope, almost home-built, and wants to populate dark parts of Africa where we don't actually have observations happening right now through this effort. So here's somebody that didn't have a way necessarily in to have a conversation with NASA or the ability to leverage what we're already doing. And the Grand Challenge in a month and a half has already opened up a new conversation there. And so Bill G mentioned the RFI that was released as well on the 18th. We've gotten some responses back. Lori Garber is going to talk more about that tomorrow. We have a conference/workshop. It's really a technical discussion the end of September 30th, October 1 and 2, down at the Lunar and Planetary Institute in Houston. The idea there, from the Grand Challenge perspective, is to bring together as many people as we can. It's going to be broadcast virtually, and design an implementation plan, co-create an implementation plan with our partners that we don't really even know who they are yet in a lot of ways, on how we are going to address this Asteroid Grand Challenge. And so those are initially the ways for folks to get engaged with this effort.
That's a really good description. Thank you, Joe. Just one question, which was, did you refer to Bill Gerstmeyer as Bill G? Is that a thing we're doing now? So I don't live at headquarters, so I'm not used to it. Oh, is that how we do it? Okay, sorry. Thanks. Now we all know.
But I didn't tell everyone that.
All right. So, Dennis, you've got something actually new to talk about too, but because COTS is so critical, and because that really is kind of at the heart of this, just really briefly, what are kind of three elements from COTS? Arbitrary number, less or more, as you like. But what really made that work?
I think it was a perfect model for partnership. All the right things were there. You had a government commitment for services, so we had an assured market for cargo to the space station. You had the willingness of then Administrator Mike Griffin to invest in the private sector. He fenced $500 million. I was very proud of that. It became $800 million. He said, let's see what they can do. So he had the right attitude. He said, it's a risk. We have a backup.
Should I just keep
They
it
fail. Let's see what they can do. And so we were able to, NASA was able to tolerate risk, which is, for bureaucratic warriors up here, we know that's very difficult. And then finally we had the innovation of the private sector. NASA didn't create COTS, SpaceX, Orbital, all the other folks who played in that ecosystem. Maybe they didn't win, but their efforts were important. And now we have, so far, one successful partner, and knock on wood, the second one here soon. So, so we had the willingness to accept risk, the play money thrown on the table, the assured market, and the incredible capabilities of a small portfolio of companies, one entrepreneurial, one a little more established. And we had a great mix, all the right conditions were there.
Yeah, I just might add two other parts of that program that I thought incredibly important were the milestone payment approach to the structure of the program, and then frankly also the willingness to cancel one of the contractual obligations with Kessler when they did not meet those milestones. I thought frankly that showed incredible fortitude on the part of the agency at the time, and I think that willingness to look some of those milestones in the face and say those are real milestones. We're serious about this program. Really enabled, I think, a sense of NASA's commitment to this being a serious new way of doing business. But yeah, I think that there are a lot of lessons and a lot of lessons that people have in the audience from that too. I know. But tell us about now what's going on with the COTS office and JSC now. There's a new announcement. It's quite exciting.
Yeah, so we're building on the success of COTS. We're looking for new areas where there could be this intersection of NASA's long-term interests and the innovation of the private sector. And so just last week, our office issued a synopsis. So basically, it's like an RFI, but it could be the beginning of a new program that would be called the Collaborations for Commercial Space Capabilities. And it's a broad call, if you will, for areas where the private sector is working on an in-space capability, an end-to-end system, that you think might have some synergy with what Bill Gerstenmaier is responsible for, the human exploration and development of space. And so whether it's in LEO or the moon or Mars or asteroids, transportation, communications, data, whatever it is, we would like to hear about it. And all we need right now is just a page, with contact information, a brief description of the idea or the plan that your company might have. And we need that by August 7th. And based on the results of that, if there are enough companies that are doing some things that are of interest to HEOMD, then the next step would be to have a competition for Space Act agreements where there would be no exchange of funds, but however NASA would be funding our efforts to support those companies. We found one of the great lessons learned in COTS was that companies value NASA's expertise. We've been doing this for 50 years. We have a lot of technical know-how, great engineers, a lot of lessons learned, technologies and whatnot. So where we see there's going to be some of these intersections, the goal would be, if there's enough response to the synopsis, is to pick a few and go help them, knowing that those companies, when their systems emerge and are successful, we could then, like on COTS, become a potential future customer. So unlike COTS and unlike the asteroid and the lunar RFIs, this is very broad, just as long as it has some synergy with the broad EO strategic goal.
Right, and provided those conditions are met, there may be the potential for really genuinely collaborative R&D efforts on the project.
Yeah, I mean, if a company is doing something right now, let's say you're doing a lunar lander or whatever, let us know. It's something we might be interested in. You're Gerstenmaier. So, and if you think you might need NASA's help, if you don't need NASA's help, you don't have to tell us.
And hopefully you don't.
But if you think you might, and you think we could also be a beneficiary, then we'd love to hear from you now.
Yeah, and it is important to remember that a lot of the commercial crew companies' capabilities relying on NASA technology. Pika, one of the great stories, and one of the inventors of Pika, certainly in the room here, Dan Rasky, was transferred actively down to SpaceX. It was a technology that was invented at NASA, and then it was actively taught, and that is now how SpaceX does its thermal protection. And that's really returned to that old model, the NACA. So again, everything old is new again, but it's an incredibly important process of NASA being the civil space agency that helps more people, more companies, more American citizens go to space. All right, so climbing Mount Everest, tell us about it. It's really kind of one of the first histories of economic histories of the many different expeditions that climbed Mount Everest. As you said, a lot of these are public-private partnerships, but tell us about what you learned about this. I think it's one of the best analogs that we have for exploration. Right, you can find this monograph on the Emerging Space Office website. It's a PDF. I really encourage you to kind of read through it. As a short little read, it's an educational read, and it is directly looking at the history of climbing Mount Everest from the perspective of an analog to space exploration.
NASA Emerging Space. That's what you Google, and then you go down to ESO reports, and it has the whole thing. But anyway, let me tell you, when Edmund Hillary and Tenzing Norgay were on the first expedition to reach the summit of Mount Everest, they needed 12 porters just to carry the money to pay the other hired help. And it was during an expedition phase that had many analogies of Project Apollo. You take thousands of people and you create a pyramid that allows you to put a few hundred pounds of equipment 6 base camps above base camp, so that a couple fit people can make it up the last 1,500 feet. And that was the original method. 75, 50 years later, depending on how you count it, you can climb Mount Everest for about $35,000. The cost innovation, the technological innovation, the difference in approaches, the competition, all of that's been motivated, I think, by the nature of the organizations that do the work. And the nature of the organization is this: it was always a partnership. The mountaineering clubs had members who wanted to climb mountains, and they didn't have enough money to do it. And so what they did was they went to the media, they went to commercial providers, they went to the Royal Geographic Society, which in a page out of the NASA history said, we're not interested in climbing mountains, but if you want to make a map, we'll contribute money. But climbing mountains in itself is not a scientific activity. So the expeditions got really big because they had a lot of partners in them. The experience from that and the competition between nations to climb the mountain resulted in technological advances to the point where the cost fell by a factor of 10. That lovely factor of 10 that we've always dreamed about for space. The cost of climbing Mount Everest fell by a factor of 10. And here's an interesting facet of science for those of you who are playing with your own money. The price did not fall by a factor of 10. The price fell by about 33%, while the cost fell by a factor of 10. And that meant that today there are commercial providers all over the world who will give you a ticket to go to the summit. And that after about 75, 50 years of development. It shows you what happens when the true believers maintain their interest in the activity and then organize partnerships which are capable of financing that activity and make the transition from an expeditionary period where you need people to carry the money because there's so much of it, to the point where you and I can write a check and do a lot of physical preparation and do the activity yourself. You want to see an interesting graphic, we should put it up. Google line of climbers on Mount Everest, and what you'll see is a line of a couple hundred climbers going up one of the trails, just like a line of pack horses going down to the bottom of the Grand Canyon. They're tooth to tail because they can't pass each other on the way up. 500 people climbed Mount Everest last year. 350 people climbed it from the south side. And they almost all climbed it on the same day, which made for mammoth traffic jams and concerns that there really are now there's too much activity on the mountain. Translated to space, that might bring us to the day that we hoped about so much that there were too many people in space and we had to worry about them not bumping into one another. So just from a historical perspective, we're trying to look at a number of analogies to space exploration to see how they developed or how they didn't develop and what lessons that might suggest for space exploration. And again, the website is.
Yes, yeah, the Emerging Space Office website, but also, just to make clear, all of Professor McCurdy's books have insights of the quality that you hearing from today. So I really, if you have not read at least 3 of his books, yeah, you should keep reading. To follow up on that a little bit, and also ask really a shared question to Carissa, because there's a lot of analogies that have often made that when people die in spaceflight, that'll kill demand. Well, we've seen this in analogy. We have had a number of commercial expeditions that climb Mount Everest that have resulted in death. And did we see a decrease in demand afterwards?
This is interesting. The risk issue on Everest is very similar to the risk issue in space. If you climb above Everest Base Camp, they generally suggest that you get your affairs in order. The chances of you dying if you are above Everest Base Camp are 1 in 100. It's a risky business. The chances of you dying on a commercial expedition are actually quite small. Most of the people who die are on non-commercial expeditions, have things they've scraped together themselves on non-conventional routes. It's a very risky business, but at the same time, the risk has gone down dramatically. You probably know the story of George Mallory, who died on the first attempt back in the 1920s, 1924, on Mount Everest. In the beginning, the chances of dying for every person who reached the summit were roughly 1 in 3. So for every 3 people that reached the summit, every 100 people who reached the summit, 33 people died in the attempt. And it's gone down from there to 1 in 100. It remains risky. Probably 1 in 100 is too much for the government in terms of risk. And so they would spend more money to reduce that possibility. But it's a risky business, but the risk continues to decline as a result of experience, knowledge of the route, technology, weather communication, the ability to communicate up and down the mountain. If you apply to go to Mount Everest, they will ask you, do you plan to bring your computer? Do you plan to make a telephone call from the summit because it's limited time in that respect? So all of those advances in technology, which have occurred as a result of experience, reduce the risk and encourage more people to become interested in it. And as incomes go up, it's more affordable to people who don't have to be New York socialites and wealthy benefactors to do the climbing. But we start to realize the dream that we dreamed for spaceflight, and that is that ordinary people can do it. The winged gospel in aviation that nobody believed in 1904, that a time would come when anybody could fly, and it would transform the world as it has.
Yeah, that's another excellent history book, The Winged Gospel by Porn. Is it Joseph Porn? Yeah. Another really good one about the culture of early aviation and how that was shaped by private sector activities. So, okay. Risk, so what would you do?
The question of risk and safety is a really interesting one. Heritage said maybe 1 in 100 is too risky for the government. And a really important part of that question is, which part of the government are we talking about? So let me talk a little bit about a different kind of public-private partnership that I think has been quite successful, and that is the FAA's role in regulating commercial launch, commercial spaceflight activity. The Office of Commercial Space Transportation, within the FAA for quite some time, was established because you used to have to go to something like 16 different agencies if you wanted permission to launch a rocket, and that seemed inefficient. So it was established as a one-stop shop with a really interesting combination of roles. It's got a regulatory role and it's got a promotional role, essentially a role to help the U.S. develop its commercial space industry, commercial space transportation industry. So there's a very interesting tension right now that I think is being very thoughtfully navigated by both parties, where NASA is asking the question, what is an acceptable level of risk for NASA in pursuing its mission, in working with commercial spaceflight providers and putting NASA personnel, NASA astronauts, on those vehicles? What's the appropriate level of risk? How do we view that from a mission success standpoint? And then there's a different question, which the FAA is responsible for answering, which says, we as a government have an obligation to the American people to make sure that they are not put in danger inappropriately and unnecessarily. We don't want third parties who are uninvolved to be injured, and that's been a long role that the FAA has had to protect people, many kind of launch. In addition, there are people who are choosing. There will be people who choose to fly on tourism flights. What's our obligation to them? How much should we, what risk is it appropriate for them to take? And there's I think, been a very effective dynamic of engagement with the industry. And I'm not saying that everybody is happily skipping along hand in hand. People have different views about what the right answer to that question is, but there's a really active dialogue that says, well, there's a principle that people making that decision should be made informed consent. They should know the risks they're facing. They should be allowed to take those risks within some limits, and defining what those limits are, and defining what informed means, and defining how long that goes and how that works is an ongoing process. And if you have an interest in it, I very strongly urge you to engage with the Office of Commercial Space Transportation, because it really has worked to make that an inclusive discussion. The other thing I'll note is we did a study recently on suborbital spaceflight, and we looked at multiple markets, and it's a fascinating study because it is the first spaceflight market that I have seen where the dominant demand appears to be commercial, not government. That's just huge. It's just transformative. In doing that study, we were trying to kind of get our arms around what's the initial demand, and so we sort of ground ruled off the table the question of a dramatic accident or a very serious event. We said, assuming an appropriate level of safety, and we kind of tried to baseline from there. I will tell you that almost everyone we talked to had a question, had this question: what happened? Does it shut the industry down? What's an appropriate level of risk? And there's a tendency, so there's a very broad recognition, it's an important question. There's a tendency to kind of leapfrog to a gut impulse answer, depending on your frame of reference and your kind of preferences with regard to the outcome. The two gut impulse answers are absolute one accident, the industry dies, which I don't think is consistent with our historical experience of many industries. And the other answer is, people know that this is risky, and we should just charge forward and let people accept that risk in an unlimited way. And I think that is very unrealistic given the concerns of the many political actors involved in the process. And so it is a great question, but it's not one with a simple answer. And it is one that I do think you'll be stumped to know, amenable to analysis.
Right, and that's a great way to think about it. I'd also encourage people to read John Krakauer's Into Thin Air, because it details a fatal expedition of Mount Everest. Fatal commercial expedition. Yeah, that's right. And not only is it a personal tale of someone who is involved with that, but it is also an analysis of how the industry responded, how the culture responded, how the different climbing clubs responded, and it is a really, really interesting insight into that process.
Still in business.
And exactly right, and they're still in business and taking a large number of paying customers of Mount Everest. Well, we're going to open to questions in just a bit, and I just want to give Robbie an opportunity to tell us, what do you have in store in the next year or so for Planet Labs?
Sure, well, it's really exciting. I'm very happy that we were able to announce our company's existence, and after launching a couple of satellites that were very successful and showed some imagery. But we, at the end of the year, are going to launch the world's largest Earth observation constellation. The data that we're going to make available is going to be extremely useful for the planet. We're going to be able to see change over time in an unprecedented way. And that is something that we feel is extremely important for people to make better decisions. Because when they understand contextual information about what's happening, then whether you're a business or whether you actually are a non-profit, you could actually use the same information to make better decisions. So we're going up on the
first Tauri's launch at the beginning of the year, and hopefully that will still be on schedule. And their next test demo launch is going up, I guess it's in September, and then with that success, then we'll be in space.
So did I hear you kind of bury the lead there, that you are by the
End of the year, going to launch the world's largest remote sensing constellation ever?
That is correct.
Yeah, he just said that kind of softly. Okay, well, we have a couple questions online, but we also have, of course, Mike in the audience, so I like people who are in person. So let's take a question from the audience.
I'll go first then. So I'm actually gonna voice partly a question that I've seen on LinkedIn, but it was bugging me for a while. Would NASA require to become a private organization, and what would that entail, and what would be the consequences?
I mean, NASA is a federal agency, so unless through some elected process, that happens, I don't see that as a sensible question. I see lots of parts of it, and I can see it creating programs, but it's a question on the post office, right? You have DHS and you have FedEx, but there's still a post office because there is a requirement on the target government for the nation to provide a particular level of service. So I think the questions about FFRDCs and centers are interesting ones to ask, but the question of privatization of NASA is a insufficiently sensible one given what its role is. We need it. The reality is, you look at how much money has been raised in the private sector over the course of the last 10 years. It is a lot, and it is growing. But it still doesn't match for human spaceflight for the last 10 years, a single year of humanity's budget. And if we're going to move out into the solar system, it is absolutely critical that we have a national support structure, both technical, programmatic, financial, infrastructure, that will enable that to happen. That's what a public-private partnership means. It means having an agency whose responsibility is not just to explore itself, but to enable the broader population of companies, nonprofits, and individual citizens to do it. And thinking about how we do that effectively is the important question to ask.
Hi, my name is Debbie Lee Wilkinson with the Open Luna Foundation. We're looking at sending people back to the moon. So risk is something that we looked at and talked about, and it was actually even a few years earlier, I was at the Four Frontiers Foundation working, and we were discussing this. And then I left and just went outside for a break and walked along a street that should be 35 miles per hour car whizzing past me, and really no sidewalk, and I needed to get around. There was a creek there. So, and it was at that point that I realized that, we keep thinking about risk and think that, the space is going to be, if you wanted zero risk, you wouldn't go to space at all. And then I kind of realized that it's like, there's no such thing as zero risk. And it seems to me that that's the misperception that people have. And the metric that I thought would be a good one is space doesn't have to be any more riskier than driving to the airport during rush hour traffic. And of course you see that with the airlines too, that it's actually safer to fly than to drive if you looked at the risk numbers at the, so I don't know, does that sound like I'm on the right track, or?
Just a quick note, there's a very classic case that you get when studying public policy, and it's the baby in the well. And what it speaks to is this question of, is there a value to human life, or what is an acceptable level of risk? And it gets very much that. We all live every day with embedded risk in our lives. We get in, every single one of us in this room almost certainly has been in the car in the last week and is exposed to a fairly predictable level of probability of death. We as a society respond to that quite differently than we do in terms of the money that we're willing to spend to reduce that risk, the degree to which we accept it, than we do to the risk of an individual, and that's the baby in the well. There's a terrible accident, and there's this huge mobilization to rescue this one individual. You could make the argument that given how much money you're spending, you could save 100 individuals if you spent that money on better stop signs and highways. And we are never going to make that choice. So there's a difference between individuals at risk and general statistical risk. And it's a really important difference in terms of how decisions get made and how governments sort of regulate.
One back and then up here.
Here. You talk about risk and you talk about, people go to Everest and they die, but it seems like particularly the commercial suborbital industry, people will be a lot more prominent. So if you have an accident with Justin Bieber, or Leonardo DiCaprio, people will look at that and say, holy shit, I don't have to go there. All this thing does is go up and go down. That's a risk I don't want to take, and the market could collapse. Whereas you don't have a lot of celebrities going and climbing Mount Everest, and it's not as high profile, and there won't be video of them dying on Mount Everest necessarily. So if you can deal with that.
Well, it's an interesting point. We have had celebrities who certainly would back into aviation. What's some historical perspective on that question?
Catching me on celebrities in aviation, and Amelia Earhart obviously became a celebrity by dying in aviation. But you stumped me with the question. I hadn't thought of Justin Bieber. And I'm not sure what value you would place on his life.
It's really not me, it's millions of teenage girls.
I still think of the Everest numbers. I think Everest is in there. K2 is much worse, but it's not the object of commercial expeditions. But, the chances of you not making it home above base camp are 1 in 100. For every 100 people who go into the ice field or come up the North Pole, one of them is going to die in some respect. But for Russians, it's even higher. There are ropes set on the ice field, but you have to pay to hook onto the rope, and the Russians always try to sneak around the ropes. Their attitudes toward risk are much different than ours. So there's an international component to this. But the mountaineers accept those risks because they're so fixated on the objective. And I should say, too, with respect to Project Apollo, the cost estimates that were floating around the agency in 1969 were roughly 30%. That there was a 30% chance that Neil Armstrong and Buzz Aldrin and Michael Collins would not make it to the moon and back. Now, they may come home, but the mission would not be successful. And the NASA center director from the Johnson Space Center eventually said, we got to quit going to the moon because the odds are going to catch up with us on one of these missions. If Apollo 13 had happened on the Apollo 8 mission, then all of those astronauts, Frank Borman included, as a commander, would have died because they wouldn't have the lifeboat that the lunar lander provided. So there were all kinds of risks in the NASA program. The problem with the government is that it does not undertake a major exploration activity with the expectation, especially for national prestige, with the expectation that it's going to fail. And that attitude, both personally and competitively, does not exist in the private sector. And tell me if I'm wrong, but when you go into the private entrepreneurial area, isn't there an expectation that a lot of the people who do this are going to fail? It won't be you. In the population,
absolutely. That statistics
you really expect that.
Definitely do show that early companies, it's 3 out of 10. That really
That's one of the drawbacks to having the government as the dominant provider of this particular service. I'll emphasize it again. In mountaineering and in other areas like the railroads and astronomical observatories, the people who did this work never lost control. of the activity. Even when the Indian government said, gee, it's pretty close to our subcontinent, we ought to go there, and the government funded the activity, they still had a private mountaineering organization, you can think of it as a non-profit organization in the United States, do the actual climbing and the organization of the climb. So that the entrepreneurs, the true devoters, the great believers never lost control of the conduct of the activity. What is different in space is that due to the very high costs in the beginning, the government became the dominant provider, and that was something that these other activities did not necessarily go through. And I think it's made it difficult for space to make the transition to the entrepreneurial phase from a historic perspective.
So Curtis, take note, next year, you should just have Howard up on stage answering questions for an hour.
It seems to me that infrastructure is kind of a prime area for public-private partnerships, infrastructure that the government can utilize, infrastructure that the commercial emerging industries can utilize. I wonder if you could talk about some of the types of infrastructure that you think would be most important, most immediate need, what longer-term needs are, how those infrastructures could be used by each parties, and how those could be evolved as public-private partnerships.
So, rather than be government official to answer that question, I'm going to ask our actual entrepreneur and spacecraft builder what he thinks we need in terms of infrastructure. You can answer that more generally than just, of course, small salaries.
For us. So, infrastructure, I would think, is well, back to Kurt's talk. International Space Station is now a pretty good infrastructure that you can do a variety of things from there. And that takes out a lot of the things that you would have to do beforehand, right? And so people deploying satellites are actually plugging in into some standardized modules, makes it really easier for people to do that. And I think the infrastructure question, it depends if you're really a launch vehicle or you're a satellite side. And those are the two major elements that play into the total life cycle cost of doing something in space. And on the satellite side, knowing physics and understanding how to build technology, you can go ahead and use things outside of aerospace in order to decrease your costs in order to do that. So the infrastructure that, for instance, we are leveraging is not necessarily in the aerospace community, where there are true market forces and there are billions of dollars that go into investment in those types of, in other consumer electronic device industries and so forth. So that is kind of answering your question about what type of infrastructure that an entrepreneurial company can make or can take advantage of. It's not necessarily just from government, but it's also from other industries.
It's a pretty big question. Who else has thoughts on infrastructure? Dennis, you thought about infrastructure. Come on, you can do it.
Well, if we knew where we were going, we'd probably tell you what we needed.
Behave yourself, Dennis.
So pick your favorite vision, and you can almost imagine what kind of infrastructure. But there are several things that are in common. Of course, transportation, cargo transportation, crew transportation, communications, refueling potentially. These are the common denominators in any kind of space activity, and so we're very interested to see what's out there, what the industry is planning to do, and if we only knew what we were going to do, then maybe we could pick a few potential winners of some synergistic activity.
The only thing I would push back on that is that I think this collective we and where we are going is a little bit simple and actually not appropriate for thinking about what we're going to have as an economy and a community in terms of capabilities. We get to go lots of different places depending on how many resources we have at our disposal and how much those things cost. And I think what's really exciting is that we're entering a period where we don't have to come up to a single place where we are going to go. I think that that is what this next age has in store. It's a potential for a lot of us to figure out, well, you want to go there and I want to go here, and guess what? It doesn't cost all that much, so I'm going to organize my resources to go where I want to go with my friends. And that's exactly what exploration looks like.
Well, in fact, what the private sector's doing and where you are going could impact NASA's plans. It may become easier.
Right, and NASA's role is that we're increasingly seeing itself as an enabler of many of those capabilities. When one speaks about space development capabilities, that's what one's alluding to.
Just a preparatory, you're discussing the risk factors. I like to look at the age of exploration, and you look at the risk of the sailor on Magellan's ship or Drake. So I think the risks that we look at now are quite different from the ones that settled this country and the Americans. My real question, though, is, I'm Gary Bickford with Space Finance Group. I was recently at a discussion with someone online, and he asserted, and I disagree with him, that the ISS program and so forth, the NASA should basically be charging the full price for every commercial company that wants to do something in space. And this should all be funded by private money, and the ISS should be self-sustaining like that. And I'd like to hear your comment on that.
Is there a specific view in that? No. Okay. Someone want to take that one first? Carissa, you've had some thoughts. I know. She's got some thoughts. And I'll share some.
Very quickly. So, if there were a robust commercial demand to support a massive on-orbit platform, there would be a massive on-orbit platform supported by a robust commercial demand. It's not a really hard equation. So to say that it should be self-sustaining, great, but it's not so. But let me offer now, because I think that the opposite of self-sustaining is interpreted as wasteful government subsidy, and I don't think that that is the case. So in the 90s, and I'll use this as an example to speak to how NASA is doing a really innovative, good job in some respects with regard to innovative public-private partnerships. In the 90s, we did a study looking at external pallets for stations. The space station office said, we're getting some pressure. We should make this available to companies. Find out what companies will pay. And so we trotted off and we did our analysis, and we came back and said, companies will pay $20,000 to $200,000. The space station office said, well, we calculated our costs and we loaded them up, and the fully allocated cost is $2 million. So, well, there you go. So the question is, is getting $0 for your $2 million fully costed asset the right decision, or is getting $200,000 for that asset the right decision? And it depends on what the marginal cost of the government is, what the opportunity cost of the government is, and what the long-term benefit of making that available to a company is. And so it's that's a meaningful and useful frame of reference to say it should be self-sustaining is not. We tried that on the ground too with the Centers for the Commercial Development of Space, and that to say they should be self-sustaining is not true.
Going to station is free. We won't charge you. You'll have other costs. We won't charge you because we want to see return on the investment.
We do pay taxes too.
You already paid.
Right, and I'll just add one thought, and we'll throw to you, sir, for the last question. The ISS really is NASA in that kind of exploratory role, not necessarily exploring in a physical, geometrical space sense, but it is exploring how do you develop an economy, an economic ecosystem, with people, with inputs, with outputs, with goods, with a variety of users. It is exploring that role now. And what we need to do from a conceptual standpoint, and one of the things that's very nice about this conference is it attracts a lot of people who think deeply about the concepts of space development and moving off this planet. How do we manage that ecosystem? What can we do to increase utilization, increase the amount of economic and social return from activities? What kind of investments do we need to make in order to validate certain types of microgravity phenomena that could actually be valuable. That is a traditional government role. The risks are very high. That type of basic research is very important for the government to continue to do. And I think that really is rightfully an important focus for the agency at the time. Sir?
Tom Coughlin, Coughlin Associates. I had a question, maybe a little bit of a different twist on things in terms of new models for diversification of financial risk. There was a recent successful Kickstarter campaign funding a space telescope. And I'm just curious about, if there are some other, get your folks' reactions on other ways perhaps of funding and actually getting additional interest in projects down there.
Yeah, it seems one for Jason and Robbie there. They're in the nexus of that world.
Really excited to see the success that that Kickstarter campaign had, recognizing that part of the challenge with the Asteroid Grant Challenge is one of financing, because the NASA funding for this effort is small compared to the difficulty ahead. And so I don't want to try and decide what the financial model might even look like. Part of the core of this grand challenge is to begin a conversation with people that are a lot smarter than I am to come up with solutions that we haven't yet thought of. And so the RFI was an initial process to do that. We want to begin in a face-to-face way later this fall. And so rather than cloud it from my perspective, I'll say that huge fan of what Kickstarter pulled off and remain wide open to additional solutions as we head down this Grand Challenge path.
Robbie, you've seen a lot of Kickstarter. You're shaking your head, Bill. You got nothing to say. Venture capital money all the way.
Well, the best money is customer money, of course. In aerospace, at least, though, to get started, there are a variety of ways. You can do that through grants, through contracts, through Kickstarter, also from venture capital or via partnership within a large organization. But you should also focus on the business, and that's going to be the fuel of the company, so that you can be around to continue to innovate rather than just get started. So the more that you can be customer focused, obviously the better. Then when you do show that you have accounts receivable, then new sources of money is available, such as debt financing. If you take a look at the most robust aerospace companies, they actually are telecommunication companies. And if you take a look at how they fund themselves, it's all with Export-Import Bank, very, very low interest loans. We are in a strategic industry, so countries do want there be economic activity, whether it's on the satellite side or on the launch side. But you definitely, but of course that financing, that's the lowest amount of risk that they will take on. So once you get to that point of focusing on your customer, having some revenue coming in, then better sources of financing are available.
Well said. All right, final comments from Dennis, Howard, or Carissa? Yeah, on the question of Kickstarter or anything else? Anything? No, Howard? Final words of wisdom for us?
Final words of wisdom? Well, I would just encourage people to look at what makes up the difference between a government contract program, government supplied activity, and a public-private partnership. It also includes prizes in public-private partnerships. They're fundamentally different in a very boring way. And we've been talking a lot about NASA, but NASA is not the problem. The problem is the Congress, fundamentally, in the appropriation process. NASA is an organization which, as a result of congressional procedures, allocates its financing through an annual budget. And the focus is on basically the control of costs on an annual budget. I don't know business activities that do it that way. They're really more concerned with cost management, with capital budgets, and with the spending rates for various programs. But this tends to, if you will, mess up the governmental perspective in ways that does not encourage innovation and does not encourage cost savings. So it's not NASA's problem. It's the manner in which money is allocated to NASA for spending. Private sector operations and students at MIT building robot cars use a fundamentally different approach, and so do people who are organizing expeditions to various high mountains on the surface of the Earth. And that, I think, gives them a competitive advantage in technological innovation and in cost innovation that the government doesn't have. Government still plays a role, but it's important for the development of these areas that the private and nonprofit sectors also play a role, because their approaches to the problems are different.
I'll just say one final thing in reference to the crowdfunding case. I'm a student of history, and actually the first instrument of space exploration of any size in this country was crowdfunded by the citizens of Cincinnati in the 1840s, inspired by the presidential inaugural address by President John Quincy Adams, who said that this nation needed observatories. And of course, Congress didn't actually go along with the President's plan. They said, no, we are not going to have a federal symbol like a national observatory. So they didn't get one. But his words inspired Officer McKnight Mitchell and the citizens of Cincinnati to collectively put their money together and buy a Fraunhofer lens from Germany and build the third largest refractor in the world, essentially to prove that in Cincinnati, Ohio, in the 1840s, the citizens of America could build an instrument of space exploration as large as the Tsar of Russia's. And that is actually what makes this community and the American spaceflight and space movement so robust. People in this country want to go, and they put their own money to make it happen. So, thank you, and enjoy the coffee. And thank you to our panelists.
Thank you once again, Alex, Carissa, Howard, Dennis, Jason, Robbie. Please join me in another round of applause.